So now I'm going to go ahead and show you some examples of lesson 15 and show you the differences between that and lesson 14 and 13. So here I have a problem from the lesson 15 exercises. And what I did up here is I put my assumptions and my standard deviation. If you go, I'm sorry, I don't mean to go to that. If I go to the handout for lesson 15, remember, this differs because it deals with proportion, but these proportions are different from the ones you're thinking of with lesson 13 and 14 because you're actually using proportion data and you're not really given the means that we've seen before. So remember, you've got to make sure these formulas are true, and then if they are, you can use the standard deviation. And I'm going to walk you through it. So the first one is in a package of Flintstones real fruit snacks, 14% of the pieces are Bam Bam snack pieces. A sample of 87 snack pieces is selection. What is the probability that the proportion of Bam Bam snack pieces in the sample is between 0.167 and 0.20? All right. So what I'm going to do is I'm going to take these up here and I'm just going to fill them in because I want to know if they're true. So let's do this. So do this. So then if I put, 87, and this is going to be 0.14, and this is going to be 87, and this is going to be 0.14. All right. So I want to make true statements. So I'm going to bring up my calculator, turn it on. So 87 times 0.14 gives me 12.18. So this is a true statement. And let's do the next one. So if I go here and I do 87 times, and I need to put it in parentheses, 1 minus 0.14, close it, and then 74.82, so that's true. So then that means the next thing I can do is do this. Oops, come on, take the whole thing. I'm going to put this down here. Okay. All right, so you might be asking, where did I get the 87 and where did I get the 0.14? Let me go back and do that. So the proportion I'm working with, I'm going to put it as a little baby p, equals 0.14, and that's converted that, okay? So then how about the sample size? And it's 87, because I don't want to even jump more into the problem until if I know I can use it. So since I have everything laid out, I'm going to do this. I'm going to do 0.14, and then this is going to be 87. Okay, since it's true, this is going to become my sample, my standard deviation. Let me show you how to put it in the calculator. I'm going to do this in steps. My first step is 0.14 times parentheses 1 minus 0.14, and I'm being really careful with the parentheses. I get 0.1204. I'm going to divide that by 87, and then I'm going to square root it. Watch while I do the square root because I don't have to write that whole long string over again. I'm going to do hold on, sorry about that. Second square root, and then I'm going to do second, and I'm going to go down here and I'm going to grab, you see where the negative sign is? I'm just going to click on it and it puts ANS. That means it's going to take this last answer and put it there, close the parentheses and put it there. So my standard deviation is 0.037. I'm going to give it that many decimal places. Okay, so now I can start to solve the problem. So remember before I said your mean is the same as your proportion, so that equals 0.14. So my standard deviation, 0.037, and then I need to look between 0.647 and 0.2. Okay, and the big thing about this again, sample size, I'm gonna give it a different color, and this time proportion. That's what makes it different. That should be screaming to you, oh, this problem's different. So let's put everything into the calculator. Okay, because again, it wants the probability. This is a normal CDF problem, normal CDF. So let me go ahead and put it in there. Okay, clear it out. So then I'm going to do second distribution. I'm going to go to normal CDF, and I'm going to do 0.167, comma, 0.2, comma, then the mean, which is 0.14, it's just the proportion, and then our new standard deviation, 0.37. Close it, and then I get 0.103. Mine answer is a little bit different from the one into the book. Just remember, I'm gonna be really careful when I grade your test and everything. And if you think you have a little bit of a slightly different answer due to rounding, let me know. So I'm gonna do this, okay. 0.1803, which is different, slightly different. You could even go back, and if you wanted to, you could have taken that whole number we got for the standard deviation and put it in. I'm just rounding for convenience sake. Okay, let's do the next one, okay? So it's basically one and the same thing. So let me just do this. I'm going to do, okay, so the proportion for this one, it's because insurance companies state that 80% of all drivers buckle up before riding a car. A sample of 320 drivers is selected. What's the probability of the proportion of drivers in the sample buckled up before riding the car is greater than 0.87? So let's do this. The proportion is 0.80. Sample size is equals 320. Okay. So I got to go back up here. I'm going to grab all my stuff. Oops, sorry. Go up here, grab it again. Gonna fill it in and see what we get. So this is gonna be 320. Let me do this. Let me get rid of the and so we can see it easier. And this will be 0.80. And this will be 320. And this will be 80. All right, so let's do this one first. 320 times 0.80 equals 256. So that's a true statement. That's huge. 256 is so much bigger than 10. So let's do the other one. 320 times 1 minus 0.80 equals 64. So that's a true statement too. I don't know if this might help us something. If I added 256 and 64, I'd get 320. All you're basically doing in that step is dividing your sample based on the probability. That's all that's going on there. No tricky math. It's just they gave you a formula to solve it. Okay, since it's true, we can put this in there. This is 0.80. This is 0.80. And this is 320. Okay, so let's put it in the calculator. I'm going to do it as one step. Let me show you kind of how complicated it is. Second square root, open the parentheses, 0.80 times, new parentheses, 1 minus 0.80, close parentheses, divided by 320, close parentheses, enter. Okay, so I get 0.02236066798. So I'm going to do 0.022. Okay, so what do I have again? I got the mean, which is the proportion, equals 0.80. Standard deviation equals 0.022. We just got that. So this is a normal CDF problem because it wants greater than 0.87. So 0.87, oops, sorry. And this is an inverse or normal CDF, normal CDF. Okay, so let's put it in and see what we get. Figure it out again. I'm going to do second vars normal CDF. So then I'm going to do 0.87 because it's a greater than, and then I'm going to do 1 second, comma, 99. That gives me positive infinity. Go here, do 0.80, comma, and then I do here and do 0.022. Okay, so now something weird's going on. I have that e to the -4. And again, my numbers are off a little bit. I think it's because I didn't include more of the standard deviation. So I've got 7.1, excuse me, 7.318. And I'm going to do that e to the -4. All that means is this, 0.007318. So that means this e to the -4 means move your decimal places 4 places to the left. So if I had it here and I moved it over, that's what I got. Again, my numbers are off because I'm rounding a little bit different on the standard deviation. Whatever the videos have told you in the guide, go ahead and do that. I think I recommended in my lesson help to do it once it is 2. So that was my mistake. But I really just wanted to show you how to do it. So again, for the homework, I would round with 2 decimal places. Let me see if that would help my cause. So I'm going to do normal. And I'm going to do 0.87, comma, 1 second, comma, 0.80, comma, and then 0.02. Close it. Nope, what did I do wrong? Did something wrong. Let me figure it out. That really changed it. So you probably do want to be making longer decimals, right? So I hope this helped. I'd go back and check your the videos that they posted for the standard deviation, but I just wanted to show you more of what was going on. If you have questions, let me know.